All right, so now we're going to do section 3, and we're going to do proofs with parallel lines. We're going to show how we can use parallel lines to our advantage. So first thing we're going to start with is our corresponding angles theorem. So go ahead and pause the video and write the converse, and then start it back up and see how you did. All right, converse of the corresponding angles theorem. The corresponding angles theorem says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Well, it turns out the converse is also true, which states if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So if the corresponding angles are congruent, then the lines are parallel. Or if the lines are parallel, the corresponding angles are going to be congruent. Our next one, the alternate interior angles theorem. Go ahead and write the converse, restart the video, and we'll talk through it together. So the alternate interior angles theorem says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. The lines are parallel, then the alternate interior angles will be congruent. Well, if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So if the alternate interior angles are congruent, lines are parallel. I'm sensing a theme. Go ahead and do the next one. Pause the video, and then restart and see how you did. All right, alternate exterior angles theorem. Two parallel lines cut by a transversal, and the pairs of alternate exterior angles are congruent. If the lines are parallel, then the alternate exterior angles are congruent. Well, what about the converse? If two lines are cut by a transversal so that the alternate exterior angles are congruent, so that what we know is the angles are congruent, then we can conclude that the lines are indeed parallel. So if the angles are congruent, lines are parallel. If the lines are parallel, the angles are congruent. And then let's do this last one. Pause the video, write the converse to the consecutive interior angles theorem, restart, and we'll move on together. All right, consecutive interior angles theorem. It is the one in the group that's different. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. And we talked about all these angles in the previous section. Well, the converse is going to help us out because if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So consecutive interior angles supplementary, they add up to 180, then we know the lines are parallel. So let's look closer at this. So corresponding angles converse. If two lines are cut by a transversal so the corresponding angles are congruent, then the lines are parallel. We just talked about that. So if this is true, then it means this is true. So if this, then this. So if we start with the angles, we know about the lines. If we know about the lines, then we know about the angles. So let's do some examples with some problems and see how this helps us. Find the value of x that makes line M parallel to line N? Well, these are consecutive angles. So our corresponding angles theorem, these are corresponding angles, I'm sorry. Our corresponding angles theorem tells us that if these angles are congruent, then the lines are parallel. So we have to make these lines congruent. So if their measures are equal to each other, so 3x, so when this is true, m will be parallel to n. So let's solve. Let's get the x's by themselves. Divide by 3. So when x equals 20, m will be parallel to n. Let's look at another one. Now this one doesn't set up quite so neatly. We have to think about what we're dealing with. So what value of x makes line M parallel to line N? Well, corresponding angles would make this 72. Alternate exterior angles would make this 72. So far, nothing is matching up. Well, here we have a linear pair, which is supplementary. So 108 plus 72 is 180. So that's true. So this would have to be 108 as well, because that's also a linear pair, north-south there. So 108 plus 72 is 180. If that's true, then m is parallel to n. Well, 108 and 4 times x plus 5 are corresponding angles. So we can say when 4 times x plus 5 equals 108, they're going to be parallel. Or if 4 times x plus 5 plus 72 equals 180, because corresponding angles will be right in the same side of the transversal, same place against the line. So either of these things are true. So let's go ahead and distribute. So that gives us 4x plus 20 equals 108. Subtract 20 from both sides. 4x equals 88. X equals 22. So when x is 22, the m will be parallel to n. But what if we had done it the other way? Well, let's find out. Well, when we distribute, we get 4x plus 20 plus 72 was 180. Combine our like terms. 4x plus 92 equals 180. Let's get the x's by itself. So we get 4x equals, well, 180 minus 92. 180 minus 90 is 90. Minus 2 is 88. So x equals 22. Either way we do it, we get to the same result. That's how we know we did it right. So why don't you go ahead and take a stab at this one, pause the video, solve it, and then restart, and we'll compare notes. All right, so find the value of x that makes m parallel to n. Well, we've got corresponding angles. Turns out this is actually a minus in there. So 140 equals 2x minus 4. So we add 4 to both sides. 144 equals 2x. So when x equals 72, m will be parallel to n. All right. So pause and answer this question, restart, and we'll see how you did. All right. So can we conclude that line M and line N are parallel? Yes. How do we know? Well, right here, we have a line. So right here, we have a linear pair. So this has to be 75 degrees because the linear pair is supplementary. Well, the corresponding angles are congruent. They're equal to each other. So by the converse, the corresponding angles theorem, M is parallel to N. So all we had to do was show that they were congruent, and then that's true. So let's talk about the interior angles converse. Because it works exactly the same way as the corresponding angles converse. If two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So if the angles are congruent, the lines are parallel. So if this is true, then this will be true. That's what it tells us. If the angles are congruent, then the lines are parallel. Same with the alternate exterior angles. If the lines are congruent, if the angles are congruent, then the lines are parallel. And the last one's the consecutive interior angles converse. So if two lines are cut by a transversal, so the consecutive interior angles are supplementary. So if the measure of angle 3 plus the measure of angle 5 equals 180 degrees, then line J is parallel to line K. So if they're supplementary, the lines are parallel. So if they add up to 180, line J and line K are parallel. And let's do a quick proof and prove that it's true. All right, so we're going to start with our given. Angle 4 is congruent to angle 5. Given. Then we're going to say angle 1 is congruent to angle 4 because of vertical angles, which we showed back in previous videos. So angle 1 is congruent to angle 5. And that's just our transitive property. And 1 is congruent to 5. We have G is parallel to H. The corresponding angle converse. Super, super easy. All right. So the alternate so we just proved that the alternate interior angles will make lines parallel. So let's talk about now the transitive property of parallel lines. Two lines are parallel to the same line. If two lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q, P is parallel to Q, and Q is parallel to R, that means, therefore, P is parallel to R. So if P and Q have the same slope, means they're parallel, and Q and R have the same slope, which means they're parallel, then P and R have to have the same slope. So that's our transitive property. So here we have our American flag, and each stripe is parallel to the one immediately below it. So S1 is parallel to S2, S2 is parallel to S3, and so on. So since S1 is parallel to S2, S2 to S3, S3 to S4, S4 to S5, all the way down to S13, we can say, therefore, S1 is parallel to S13. I don't know why I dotted that, but that's going to be true. And that's our transitive property of parallel lines in action. So what does that mean for us? So let's find the measure of angle 8, which is this guy way down here. If we know that P is parallel to Q, and Q is parallel to R. So if P is parallel to Q, then this angle here has to be 115 degrees. That's our corresponding angles theorem. Q is parallel to R, so this has to be 115 degrees because of the corresponding angles theorem. So 8 and 115 are a linear pair. So the measure of angle 8 plus 115 equals 180. Well, 180 minus 115 means the measure of angle 8 is going to be 65 degrees. And we are done.